Hello everyone, welcome back to our channel. I am Nikhil Kumar. Before we jump into today's lesson, let's quickly solve a task which I gave you last time. It was a practical one, like creating a user, creating a group, and giving a controlled sudo access. So let's walk through the solution together so everything is clear. In the previous video, I gave a task to create a user deploy, create a group frontend, and add a deploy user to a frontend group, and also add a permission in the sudoers file. So let's do it very quickly. So here first we create a user with a name called deploy. So for that we can use command user add deploy. So deploy user got created. Let's verify it using id command. Yes, it got created. Now update the password for the same. So pass wd deploy and need to enter the password. So the password also got set for the deploy user. Then we need to create a group called frontend. So for that we can use group add command with the group name that is frontend. Now we have a both user and group. Let's attach a deploy user to a frontend group so we can manage access easily. So for that we can use user mod -ag frontend and the username that is deploy. Now the user deploy is a part of a front-end group. So let's verify it very quickly. Now I can see the front-end group is appearing in the group section. Now comes the important part. We want to deploy to run exactly one privilege command, nothing else for that. So this time I will add access for the group instead of a user. So let me update the sudoers file. So vi sudo, and here we can see in the last video we have created an entry for the DevOps user, but this time I created a user and the group both. So I am going to add a permission for the group. So whenever I need to add another user in the front-end group, the access will automatically apply to that particular user. So if we scroll down here, so here if we want to add a permission for the group, so we need to use a percentage sign here. So here I need to use percentage and the group name. So here the group name is frontend, and then we need to specify all equal to all, and then the no pass wd equal to user bin systemctl, because we need to give an access to restart any service. So that service can be Docker, Apache web server, or Nginx web server. So I'm going to give an access to the HTTP service. So restart httpd. So whenever we need to give an access to the group, so we need to use this symbol, that is percentage symbol. This is mandatory because using this only the Linux system will get to know this is the group. But if we are having a normal user, we can specify using the normal username itself. Now let's save and exit. Here you can see we got an error. Why? Because we have used the vi sudo. If I haven't used the vi sudo command, I am able to save the file, but this error will not show up. That's why vi sudo is very useful to prevent from our system failures in case of editing a sudoers file. Otherwise we will be logged out. So let's rectify that. So we need to press E here to edit the sudoers file again. So here if we see here, there is a equal to. So instead of equal to, we need to use a colon. So I intentionally make the mistake so that you will get to know what will happen if we intentionally make some syntax error in the sudoers file. So let me save and exit. So this time it worked fine. Now let me switch to the deploy user, su deploy. Now I am logged in as a deploy user. And now if I run sudo with systemctl restart httpd, so the httpd service is not there. So let me install it. Sudo yum install httpd, and let me enter the password. But this user is not having an access to install any package. So let me do it with the root user for now. So yum install httpd-y. Don't worry if you are not able to understand the yum or the dnf command. I am going to cover the package management in the upcoming video in very much detail. So now it's installing the Apache web server. Now the Apache web server got installed successfully. Let's switch to the deploy user. Now if I run the same command again, it's able to restart the service. But if I am trying to do some another operation using sudo, I am not having access to do that. This is a task which I gave in the last video. Now we have a solution for the same. You can cross-check your solution with this particular video. So we have built a real Linux access control exactly the way real DevOps team do. With that task completed, let's jump into today's topic. We are going to learn how Linux actually runs application, what processes are, how services work, and how systemd manage everything inside the system. And this is one of the most important DevOps skills. So let's start with the process. A process is simply a running program. When you open a file, start an Nginx service, or run a script, a Linux creates a process at the backend. Every process has PID, that is a process ID, PPID, that is a parent process ID, user who owns it, and the CPU and memory used. Linux sees everything as processes. Let's see processes in the action. Let's get back to our terminal. And let me clear the screen and get back to the root access. Now, if we want to see a process in the system, we have a ps command. So if I run ps, so this particular command shows running processes. It's the simplest version of the ps command. This shows processes only in the current shell. But to see all the processes on the system, we use ps-ef. E means shows everything and -f means full details of the processes. If I hit enter, so we can see there are lots of processes are running in this particular system. So if we scroll up, we can see some processes are running with the RK2. There is one process is running with the syslog server. Some process is running with the SSHD session. So using this, we can see the processes which is running at the backend. Now, if we want to search or look for any specific process, so we can search that using this particular command. So what we can do, so if I run the same command with a pipe symbol and grep. So if you remember, I use grep to find some text in the files, but grep can be used to find something in the command as well. If we want to use two commands together, like in this particular example, I am running a ps-ef command, but I want to give this output to the grep command. So we can use a pipe symbol. So pipe symbol, what it does, so it will send the output of this particular command to the grep, and the grep will look for the specific text from the output. So here I want to see for the SSH here. So as we can see here, it listed all the processes which is having the SSH keyword in the text. It is very useful if we want to see or look for some specific process, and if we want to see some details about some specific process. Now, if we want to see a live CPU and the memory usage, we can use a top command. So if I use top, so this command shows which process is consuming CPU. So here it shows every detail about the CPU, memory, swap memory as well. So from here we can get the memory usage, load average, and the system uptime. So when a server is low, this is the first place to check. Now to come out of it, we need to press Q. Now that you understand processes, let's learn how Linux manages long-running application like Nginx or Docker. So what is a service? A service is a process runs once and ends. A service is meant to run continuously, like SSH, Nginx, Containerd, Kubelet, etc. Services don't depend on your terminal. They are managed by something bigger, that is systemd. Let's get back to our terminal and let's see the systemd services in the action. Systemd starts services when the machine boots, restart them if they fail, and manages their log. We interact with systemd using the systemctl command. If you notice, a couple of times I use the systemctl command. So systemctl is the one who manages the systemd services. So to check the status of any service, we can use systemctl, status, and sshd. This is the command to check the status of any service. It shows if the service is running or disabled or stopped, if the service is enabled or not. It also shows the process ID of the service, which systemd file is being used to load this service, what is the memory they are consuming, what is the CPU they are using. All the details we can get from the status command. Now if we want to stop any service, we can use systemctl stop httpd. So using this, we can stop any service. So if I run the same command to check the status, systemctl status, we can see the service is in the inactive mode because we have stopped the service. Now if we want to start this service again, so we can use systemctl start and the service name, and the service got started. If I run the same command to check the status, so now we can see the service in the active mode. But here we can see it's disabled. To make it enable, we have another option, that is systemctl enable and service name. There's a typo, so it's double T. So it created a symlink at the backend. That means this particular service will be running after the reboot. If the service is disabled, if we reboot the server, this particular service will not come up. In that case, we need to manually run the service. But when we enabled it, whenever the server reboot, the systemd will automatically run this service. It's a recommended approach to make the service enable when we want our application to be running every time. Running, stopping or restarting the service is very important, but checking the logs of the service are more crucial. If your application aren't running, these services are the first place to check the logs. So for that, we can use the journalctl command. So journalctl is the command. Using that, we can see the logs for the particular service. So if I run journalctl-u, it shows logs for a specific service. So right now we need to specify the logs for some service. So if I give service name, that is shd and -f, that means it will follow the logs live. So here I can see the logs of the SS service, which is updating live here. So I just need to use journalctl with -u and the service name and the option that is -f. That means it follows it live. This is extremely important whenever we need to debug any service details. If service got failed or if some service is not getting started, this is the right place to check the logs for the same. Now sometimes you want a command to run in the background. So right now if I run sleep 10, sleep for the 10 seconds. So it's waiting for terminal to execute this command. Till the time the command is being executed, the terminal will not give a shell to me. Now it executed successfully, it gave a shell to execute the next command. But if I want to run it in the background, so what we can do, we can run the same command with the ampersand symbol. So this particular command will be executing at the background and it shows the process ID of that particular command. So if we want to list this particular command, we can run the jobs command. So here we can see this command got executed successfully. So if we want to run the same command with a bigger time span, so update it to the 1000 seconds. So again, it shows the process ID. Now if I run jobs command, we can see the sleep command is in the running state. Earlier it executed very quickly because I just gave it 10 seconds. So this time it's running around 1000 seconds. But I want to bring it back to the front. So for that, what we can do, FG foreground, percentage symbol and 1. That is the rank of this particular process, enter. So now this command is executed at the foreground. That means the command is executing on the shell itself. Now if I want to kill this, I can press Ctrl C. This is very small thing, but it's very useful in real debugging scenarios. So now we have understood how Linux runs application from the inside, and this is the foundation of Linux troubleshooting. In the next video, we are moving into something simpler but super essential, that is package management, like how we can install packages inside the Linux system. If you found this helpful, hit like, share it with your friends and subscribe for more content like this. Thanks for watching. I will see you in the next one.